So good morning students, welcome back. Today in this chapter EMI, electromagnetic induction, we are going to discuss one of the most important topic, eddy current. Okay, so let's start with definition. And eddy current is also said to be Foucault current because it is explained first of all by Foucault. So what is eddy current? Look at this is cross means magnetic field perpendicular downwards. We can represent magnetic field by two ways, dot and cross. Okay, and we are having a metallic rod. Okay, and that metallic rod executing rotation motion like this. Okay, under the influence of external magnetic field, then it produces some local current. Okay, in that object, that current is said to be eddy current. Whenever the metallic rod or metallic disc, bulk disc of conductor, okay, execute rotation motion, passing flux through it will change, and as a result of electromagnetic induction, it produces some current, and that current is said to be eddy current. Actually, the object will produce its own magnetic dipole moment. Okay, and that magnetic dipole moment opposes the source magnetic field, applied magnetic field. That's why the eddy current are opposing in nature. It follows the Lenz's law. I will explain. First we'll come on the definition. Eddy current are current induced in solid metallic masses due to rotation motion when changing magnetic flux passes through them. Simple. Whenever the object executing rotation motion like this in external magnetic field, then due to change in flux, it produces current, and that current is said to be eddy current. Okay, the most important thing, eddy current obeys the Joule's heating law. Whenever the eddy current set up in that metallic rod, okay, it produces heat, intense amount of heat, large amount of heat. That's why it follows Joule's heating law. And second point, eddy current obeys the Lenz's law. That is one of the most important point. It follows the Lenz's law. How? Actually, when the eddy current set up, object produce its internal dipole moment, and that magnetic dipole moment opposes the source magnetic field, external magnetic field. That's why these current opposes the external magnetic field. In other way, we can say, okay, what is the main reason for the production of eddy current? Rotation motion of that object. As soon as when the eddy current set up in that object, okay, the rotation of that object will stop. What is the main reason of the production of eddy current? Rotation motion in magnetic field. And as soon as when the eddy current set up in that object, its rotation will stop. That's the Lenz's law. What is the Lenz's law? Lenz's law always opposes the change in flux, the factor which are responsible for its production. If you remember to read the Lenz's law, E equals to minus d phi by dt. Lenz's law is what? Lenz's law states that induced EMF and current always opposes the rate of change in flux. Actually, due to change in flux, EMF induced, and that EMF opposes the factor, the change in flux, which are responsible for its production. Same like, what is the main reason of the production of eddy current? The rotation motion of that object in metallic object in magnetic field. As soon as when the eddy current set up, the rotation will stop. In this way, it follows the Lenz's law. Okay, students. Now, students, we'll discuss its mathematical part. We'll discuss what will be the mathematical portion of eddy current. What is? Look at, when object execute rotation motion, it induce EMF. What is EMF? What is induced current? Induced EMF by resistance. Okay, R is resistance of that conductor, EMF is induced EMF, and I is what? E is the induced EMF and I is current. And we know what is induced EMF by Faraday's law, Lenz's law, minus d phi by dt. Okay, so put here, this is minus 1 upon R, and instead he will put this d phi by dt. So this is the mathematical form of eddy current. Okay, this is a mathematical form of eddy current, and these are the properties. It follows the Joule's leading law. It obeys the Lenz's law. Okay, and what is the main reason of the production of eddy current? Whenever a metallic object, a disc like rod or bulk object, execute rotational motion under the influence of external magnetic field, so then current is set up in that is said to be eddy current. Okay, students.